In this video, we are going to talk about using quadratic and linear functions with modeling. Specifically, we're going to write linear functions and then also switch between vertex and standard form for quadratics. So first off, here's a general form of linear function. You might be used to having this letter in front of the x be a m. So having it as y equals mx plus b form. This is just function notation of f of x and then equals ax plus b. A is just the slope. B is still the y-intercept. This is just kind of keeping it in line with quadratics as well. So for a quadratic, standard form of a quadratic, which we're going to get into on the next screen, or in the next couple screens, is ax squared plus bx plus c. So just keeping a as the lead coefficient. So you're going to see that kind of consistency through pre-calc. So taking a look at this, we're going to write the equation for a linear function satisfying the following stuff in parts A and B. So first of all, I'm just going to write the linear function off to the side again. So it's f of x equals ax plus b. So the things that we need to find are the a and the b. So remember that a is slope. So the way that you find slope is you find the change in y over the change in x. So if we take a look from this function notation, I could just write this as an ordered pair. Remember, this is f of x. So this is your x value. And then this is your output. So plugging 2 into this function gives us back -2. And plugging 5 into this function gives us back 7. So we end up with those two ordered pairs. So however you want to find slope, you can do y2 minus y1 over x2 minus x1. I like to stack them on top of each other. So 2, -2, I put them in a table. 2, -2, and 5, 7. And then I just think about the change. So how far is it from -2 to 7? And that's a change of up 9. From 2 to 5 is up 3. And then slope is always the y over the x. So our slope here, our a value, is going to be 9 divided by 3, which is 3. So now we have the slope. So in this function, we now have f of x equals 3 times x plus b. So we're still looking for b. So now we're going to go ahead and use the fact that we know a couple different points here. So we're going to plug in one of these 2 points. So either this one or this one. Remembering that this is the x coordinate and the y coordinate, or you could think of it as the x coordinate and the f of x. So when we plug it into a function, so pick whichever one you want. I'm going to do this one. So I'm going to plug in 5, 7. So the function or the output is 7, okay, equals 3 times the x value of 5, and then plus b. So 7 equals 15 plus b. Solve that by subtracting 15 from both sides, and you get -8 equals your b value. So then we'll just take and plug in the b value and the a value to get our overall function. So we just end up with f of x equals 3x and then -8. And that gets you your final answer. Again, you could put y equals 3x minus 8 as well. All right, so let's do one more here. So again, I'm just going to find the slope by stacking them. So -1, 2, and then 3, -2. Change in y, so from 2 to -2 is down 4. From -1 to 3 is up 4. Your slope is always the y on top, so -4 on top, x on bottom. Okay, so change in y over change in x, and that's going to equal -1. So then we'll go ahead. This time I'll just write a y since we have our ordered pairs written as xy. So we have negative 1x plus b. Pick either of these 2 points to plug in, whichever you want. I'm going to plug in this first one. So the y value is 2 equals negative 1 times the x value plus b. So the x value of this ordered pair is negative 1. So then we end up with 2 equals negative 1 times negative 1 is 1 plus b. Subtract 1 from both sides, and you get 1 equals b. So then you can plug that in and your a value into your equation. So we'd get y equals negative 1x plus 1. So the slope and the y-intercept. All right, then getting into, and you can pause this video to get this stuff written down and then come back to hear it explained. But so for quadratics, we have, and we're going to be writing in vertex form, so we're going to be looking at this hk value here. So the h is the x coordinate of the vertex, k is the y coordinate of the vertex. So if you're thinking about a quadratic, right, it looks like this, a parabola. So it has an axis of symmetry, or a line that it goes right through the vertex and it will fold over on itself. So this is going right through the vertex. So this ordered pair right here is going to be hk. So then this line is the line x equals h. That's your axis of symmetry. So a vertical line is an x line, so this is just x equals h, the x coordinate of the vertex. So we have standard form here, ax squared plus bx plus c. You find the x coordinate, or your axis of symmetry, by doing opposite of b over 2a. So this is just finding the x coordinate of the vertex. And then you find the y coordinate by plugging that into the function. So you just plug that x value into the function. Then we have vertex form. So y equals a times the quantity x minus h squared plus k. This is also transformation form. So this h value here is going to move the parabola left or right. The k is going to move it up or down. And then the a value is going to be a vertical stretch. So let's take a look at both of these forms. So in this first one, we're in vertex form. So when we're going to go to write the vertex, it's pretty easy from vertex form. You can see it written here, essentially. Okay, remember this was in vertex form was x minus the h value. Okay, so if this is a plus, what you plugged in was a negative. So negative 3 is your h value. Negative 5 is your k value. And then the axis of symmetry, it's the equation of a line. So make sure you put x equals negative 3. So it's the equation. So make sure you have a variable in there. And then if you were going to describe the transformation here, this 2 would be a vertical stretch by a factor of 2. Okay, this negative 3 that got plugged in, that's left 3 units. And then this minus 5 out here is down 5. Then looking in standard form to find the vertex and the axis of symmetry and describe the transformation. So you need to start with your formula for finding your h value, or your x value of the vertex. Okay, so remember h is the opposite of b. So this is your b value. So opposite of 12 is negative 12 over 2 times your a value, which is 3. So negative 12 divided by 6 is negative 2 for the x coordinate of your vertex, which is your axis of symmetry as well. So x equals negative 2 for that. So to find y, you just plug the -2 into G. So we're going to do G of -2. So everywhere we see an X, we're just going to plug in -2. And then just simplify. So -2 squared is +4, which 3 times 4 is 12. 12 times -2 is -24. And then we have that plus 11. So 12 minus 24 is -12. Plus 11 is -1. So the y-coordinate of your vertex is -1. So when you plug that value back in, what do you get? And that's your vertex. So then for this one, if we wanted to write it in transformation form or in vertex form, so this is standard form, so then vertex form would be g of x equals a, which is given to you right here. So your a value is 3, and then times x minus the h coordinate squared. Okay, so the h coordinate or the x value of your vertex is -2, so I'm going to plug in -2 here. And then plus that y coordinate of the vertex, so in this case it's -1. So your vertex form is g of x equals 3 times x plus 2 squared minus 1. So the transformations here would be a vertical stretch factor of 3, left 2 units, down 1. All right, then let's look at a word problem. So in this one, we have the length of a rectangle. Okay, so the shape that we have is a rectangle. The length of it is 3 more than the width. Okay, so this length here is equal to 3 more than the width. So the width plus 3. And then it also tells us that our area is 40. So in this one, we're using area. So let's write down the area formula. So area of a rectangle is length times width. And then let's plug in what we know. So we know that the area is 40. We only want one variable over here. Okay, so you can do this as W. You could also write these as X's. So if you wanted to call the width X, then the length would be X plus 3. So the length was X plus 3. And the width was just X. So to solve this, we're going to need to multiply this out. So X times X is X squared. X times 3 is 3x. Since it's a quadratic, we need to bring everything over to one side. So we'll get 0 equals x squared plus 3x minus 40. None of those are like terms. And then we'll factor. So this has an a value of 1. So all we need to do is figure out the factors of -40. So two numbers that multiply to -40 and add to 3. So 8 and 5. And we want the 5 to be negative because 8 minus 5 is positive 3. So x times x gives you that x squared, and then we'll put the positive 8 and the minus 5 in here. So if you checked this, you'd have x squared when you do x times x. You'd have negative 5x, positive 8x, which would be your 3x. And then 8 times negative 5 would be that negative 40. So then we want to split this because anytime we have two numbers multiplied together to equal 0, one of the factors is equal to 0. So we'll split this and say either this one is equal to 0 or this one is. And then we'll solve. So subtract 8 from both sides. So on this one, you get x equals -8. And on this one, we'll add 5 to both sides. And we'd get x equals 5. So remember that x represents the width. So the two answers we just got are negative 8 and 5. Well, negative 8 doesn't make any sense because you can't have a negative length of a segment. So 5 is our only answer. So this is called extraneous. So 5 is our answer. So the width is 5 and the length is 5 plus 3 or 8.